Hello viewers, let us focus on furniture modeling. You know that AutoCAD is a software that can be used to create furnitures easily and accurately in 3 dimensions. In this video, I would like to explain the steps involved in creating the 3D model of a round table. So I'll start with the circle command. When I'm asked to give the center point, I'll give 0, 0, the origin, and for the radius, I'll enter 60 because I want the diameter of the tabletop to be 120 units. The circle has gone outside the screen, so I have to give a zoom command followed by extends option to see within the bounds of the screen. Now, I would like to switch over to isometric view. I'll just click over here to get that, or else you can give viewpoint command. I'm going to add a thickness to this tabletop. I give extrude command, and when I'm asked to give the height of extrusion, I'll enter 3 because I want the thickness of the tabletop to be 3 units. I would like to fill at this corner because this corner is a sharp corner, so I'll give fillet command. You know, fillet command can always give you a smooth corner. So I'll give a radius option, and I'll give a radius of 1.5 units, and I'll select the first edge to be filleted. So it'll ask you for radius once again. I don't want to change the radius, so I'll just give an enter. So it'll ask you to select the next edge, so I have selected it. I'll give one more enter, and I have got the corners filleted. Just give hide, but you can see that the edges are segmented. If you want to increase the number of triangles in these curvular faces, you can do that with the help of a variable that is called facet res. So I gave facet res, and it can take values from 0 to 10. I gave 10. Now give one more hide to see that you have increased the number of triangles in the curvular surface. Now you have got a smooth curve. Now I would like to switch over to an elevation. So I'll just click on the front over here. I've got a front elevation. Next, I'm going to create the central member which supports the tabletop. So I'll start creating it by drawing a polyline. But if you want to draw a polyline, you can't do that in the ZX plane. You know that you have to align the XY plane here. So what I'll do is I'll go to UCS command, and I'll go to view option of UCS command, with which you can align the UCS or the XY plane with the existing view plane. Now I'll draw a polyline starting from the origin, and I'll show the length of the height of the tabletop. And the height of the tabletop is 80 units, out of which 3 units is already given here as the thickness of the tabletop. The rest is 77, which I am going to indicate here. So I gave 77, so this polyline indicates the height of the tabletop. Now I'll draw some construction lines. I give some offsets to draw the profile to construct the central element. So I made an horizontal line here. Now I'll give one more offset of 10 units upwards. Then I'll give another 10 unit offset, and I'll give another 7.5 unit offset. So when I trace the profile, these construction lines will be useful. Now I'll draw a polyline starting from 0, 0, and this polyline is going to indicate the profile for the central member. So the next endpoint I have picked here, I'll turn my OSNAP off by pressing F3 key, and I'll simply trace a polyline. I'll just switch over to arc option now. I give arc, then I'll go to second point to draw a curve over here. Now likewise you can sketch the profile. Now I'll switch over to line mode now, and I'll click a point over here to this intersection. Then back to perpendicular. Then I'll draw an arc like this. Then I'll come back to line mode. Then I'll go back to 0, 0 and close. So this profile will indicate the profile of the central member. This profile is going to be revolved about this vertical axis. or you can revolve it about the y-axis to get that central member. So I give a revolve. I'll select the profile to be revolved. When I'm asked to give the height, when I'm asked to specify the axis, I have various options. I can use an object that can be used as an axis, or I can use the present y-axis as the axis. So I'll give y, so that will be used as an axis of revolution. Now it will ask you whether you want full circle to be revolved. Yes, I want 360 degrees. So it is revolved through a distance through an angle of 360 degrees. Now I'll draw some legs, because we need some supports here to support the center member, and these supports are nothing but legs of the table. For that, I will again draw profiles. I'll start from here, a profile, then I'll go to arc option, then I'll come back to a point over here, then I'll pick here, then you come back to line mode, then you can draw a perpendicular here, then you can draw another line, then I'll go to arc option and second point option, then I'll pick a point over here, then you can just go to line and you can close it. So this profile will indicate the profile that is going to be used to create the leg, one of the legs. So I'll extrude this profile now, and the height of extrusion I'll give as 3 units. Now I would like to see this leg in the plan view. So if you want to generate the plan view, the easiest method is you can just get rid of these profiles now. You can erase these profiles because these construction lines are no longer required. I've erased those construction lines. Now if you want to generate a plan view, you have to first take the UCS back to WCS, because that is a reference coordinate setup. So I'll give UCS command, then I'll give an enter. So I went back to world coordinate setup. Now you can just click over here on the top, or else you can give the plan command to get the plan view. Now you can see the leg here in the plan view or in the top view, but it has taken a thickness in this direction, so it is not properly centralized. So you have to move this leg in the upward direction through a distance of 1.5 units, which is half the thickness of the leg, half the extrusion height. So now it is perfectly centralized. Now I have to create multiple copies along the circumference of the circle. Now I'll give array classic command for that. I'll select the object to be arrayed, then polar array. It is basically a polar array. Then center point of the array, you can select the center over here. Now number of item is given as 4. I would like to retain that as such. Now you can just preview the array. Now it's okay. It's perfectly fine. I'll just give OK to create the array. Now I would like to switch over to isometric again to see the table which I have created. If you want, you can have various representations for this table. Now the present representation is called a hidden representation, but if you want, you can switch over to another representation that is called shaded representation. You just go to visual styles and realistic shading, you can go for, and you can orbit it, and you can view the various curves you have created for the central member as well as for the legs. Now if you want, you can go to the next higher level of representation after applying the materials. So let's see how to apply a finish to this particular table. For that, you have to give a command called rmat. Then you will get a material dialog box. In here you have the material that is required. I would like to apply a teak wood finish to this table. So I'll give, say, a teak here and give an enter. So it will search for the teak wood here in the library. So now you have various types of teaks displayed here. So I am interested to apply this particular teak, or I would like to select, for example, this teak. So I have selected it. Then you select the table, select the entire elements in the table. Just click on that. You can see that it has applied that finish over here. Just close the dialog box. Now you can just orbit it and you can view it from various angles. But this is not the realistic finish, because shading will not show you the realistic finish. For that, you have to go to rendering. So a rendering is more realistic shading after applying the finishes as well as lights. So let us put up a light for the time being. I would like to create an omnidirectional light here. So it is better to switch over to plan view for that. Now I'll give a command called light. So it'll ask you whether you want to turn off the default lighting. I'll just give OK. Now it'll ask you what type of light you want to create. I have a point light, spotlight, web light, etc. I would like to go for a point light. Point light. So it'll ask you for a source or the location where do you want to keep it. I want to keep the point light elevated through a distance of 100 units from the tabletop. The presently XY plane is kept on the tabletop. So I want to define such a location. I should make use of point filters. So I'll go to .xy off. I'll pick a point over here. Now when I'm asked to give Z, I'll give 100 units. Now it'll ask you for a source 100 units. I'll do it once more. I'll .xy off. I'll pick a point over here. When I'm asked to give Z, I'll give 100. Enter. Now you can control certain parameters like intensity, photometry, shadow, etc. So I'll go for intensity and I'll give a intensity value of 5 and I'll go to shadows. The shadow by default is enabled, so I want to enable the shadows and I'll give OK. So I've created a omnidirectional light here. See, omnidirectional light is a light which radiates equal amount of light radially into all directions. Now I would like to create a second light over here. So I'll go to light again and I'll go to point light once more. Once again, when I'm asked to give the source location, I'll use filters to define it. I'll give .xy off. I'll pick a point over here. When I'm asked to give the Z coordinate, I want the light to be lowered. It has to be below the tabletop. So XY is kept on the tabletop. So I should give a negative value. I'll give say minus 50 for the Z coordinate. And for the intensity, I'll give 5. And for the shadows, I don't want to enable shadows for this light. So I'll turn it off and I'll give an enter. So I've created basically 2 omnidirectional lights here. Now I will go to a viewpoint, or I'll go to a 3-dimensional view. I'll just zoom it. I'll zoom it. Then I can go for a render. I'll give a render and enter. So you can see that it is rendering it. It is rendering it. But the effect of light, if you want to see more, you have to create such a view. You have to create a view in such a way that you can see the effect of lights more properly. So I'll go to orbit again. I'll render it. Okay. There is a command called render rpref. That's what stands for render preference, in which you can control the size of the render window. I'll increase the size of the render window, and you can also control number of other parameters, which will be explained in detail later on a different video. So I'll give a render again, and you can see that it is performing rendering, but in a larger window. But the shadow is almost obstructing the central element here. You also have another option to render it, that using a command called render crop. You give render crop and select the 2 corners, so you can see the result of rendering right on the screen. But you will see some jaggy edges here. Anyway, these are the different methods to visualize a 3D model. You can go for shading, or else you can go for rendering for final presentation. Hope this has given you some insights on modeling, rendering, and lighting, and a bit on finishes. Thank you for your patience.